These are part one of equations of circles. For this part, we're going to talk about the center of our circles being at 0, 0. So first, definition. A circle is a collection of points equidistant from one point called the center. We can measure the distance from the center of the circle to a point on the circle by creating a right triangle, which means I can use Pythagorean theorem. So let's look at a couple of examples. We're going to find the equations for the following circles centered at the origin. In our first circle, I actually can't count over and see exactly, oh look, there's the radius. It's somewhere between 2 and 3. But I'm given a point on the circle. So I can create a right triangle right there. And I can find this length. So we're going to say leg 1 squared plus leg 2 squared equals hypotenuse squared. Our hypotenuse is this length. That's what we're trying to find because that's the radius. So we'll label that radius or r. I can count because I'm on a coordinate plane, my grid here. It's 2 and 2, so I have 2 squared plus 2 squared equals r squared. 4 plus 4 equals r squared. 8 equals r squared. Now, normally you want to simplify that, right? Like you want to say r equals the square root of 8, which is 2 square root of 2. So that would be the length of r. But you're going to see that for the purposes of writing equations of circles, I actually care more about the r squared length. And that's because I am going to do this process again using this point right here, where the point is some x and some y. So I start again. I have my leg 1 squared plus leg 2 squared equals hypotenuse squared. Let's draw in that triangle right there. So for this triangle right here, my leg 1 is some x over. So some x over. So that's x squared plus. And my leg 2 right here is some y up. And so I'm going to say y squared. And then I know that this length must be the same as this length because that's the definition of a circle. So I have r squared. But I've figured out r squared by using this process, this Pythagorean theorem for a point I knew, which means I can say that the equation of the circle is x squared plus y squared equals 8. The second example we're going to do is in some ways more straightforward than the example we just did. And that's because I can actually count my radius. It hits at a lattice point on the side here and up here and up here and up here. And so my radius turns out to be 1, 2, 3. Which means I can actually skip the process right now of finding r. So that first part where we did Pythagorean theorem the first time, that was the process to find r. So in this case, I don't need that, and instead I am going to just find the equation of the circle. So I am going to pick a random point again, x comma y. I'm going to draw in my right triangle. And remember, I know this r equals 3. So I've got leg 1 squared plus leg 2 squared equals hypotenuse squared. My leg 1 is some x units over, even if my triangle doesn't look quite perfectly like a right triangle, so that's x squared, plus some units up, which is my y squared, equals my radius squared, which we know is 3. And now I simplify that, and 3 squared is 9. And that is the equation of this circle.